What if your neighborhood could keep the power on even when the main power grid goes down? That's exactly the promise of microgrid system. This is why today we'll test your knowledge with some tricky electrical engineering quizzes. Welcome back to the CMTEQ Quiz review number 4. Question 1. What is a microgrid in the context of grid modernization? 1. A small power generation plant. 2. A grid designed specifically for urban areas. 3. A monitoring tool for grid operators. 4. A localized grid that can operate independently or alongside the main grid. What is the correct option? Just hold your thought. Let's see how the community voted. The majority overwhelmingly went for option 4, that says a localized grid that can operate independently alongside the main grid is actually what a microgrid is. But is this the correct answer? Let's go ahead and reveal the correct answer. Yes, indeed, it is the correct answer. But why? Well, to simply put it, as you can see here, a microgrid is basically a small version of your main power grid, but with the ability to operate under outage. So you can cut off this link here. The microgrid will continue to operate. So it can basically island itself in electrical terms. So this basically means this microgrid system, even when you disconnect the main power grid, it can continue to operate autonomously with its own power generation from PV, from a wind turbine, from your battery storage. It can continue supplying your neighborhood with light. So that's the promise of the microgrid system to you. And at the same time, it will connect back to the grid system when the utility is back online. Now let's see why some of these options are incorrect. Well, option 1 is incorrect because a microgrid is not just a small power plant. It's basically a combination of small power plants with generations and control integrated in a one system. And option 2 is incorrect because clearly, as you can see here, a microgrid is not only limited to urban area, it can also supply industrial plant. And obviously, option 3 is incorrect because yes, we do have monitoring tools for microgrid systems, but this alone does not define what is a microgrid. Hence, option 4 is the correct answer. Just before we move on to the next question, keep in mind that microgrid is a key element of grid modernization because they basically improve system reliability, resilience, and integrate renewable energy more effectively. Question 2, related to harmonics in power system, a very, very important topic. Question: what are interharmonics in a power system? Option 1, harmonics caused only by renewable energy systems. 2, harmonics with frequencies lower than the fundamental frequency. Okay. Option 3, frequencies that are not integer multiples of the fundamental frequency. 4, a special type of third harmonic current. Okay, what is the correct answer here? Now, before you can reveal the correct answer in the comment section to us, let's go ahead and see how the community voted for this particular question. %47% went for option 3 and 28% went for option 2. Now, what is the correct answer? The correct answer is option 3, frequencies that are not integer multiples of the fundamental frequency. But why is this really the correct answer? Let's go ahead and just have a quick insight here. Now, we know that in power system, the normal harmonics, they basically appear at integer multiples of your base or fundamental frequency. Let's say if your system frequency is 50 Hertz, then you're going to have harmonics as integer multiple of that base frequency. So you'll have harmonics at 100 Hertz, 150 Hertz, and so forth and so on, right? So basically integer multiple of your 50 Hertz, frequency. Those are harmonics, but interharmonics, they are different. How? Because they basically show up in between. As you can see here, I've got harmonics here, and interharmonics, they will show up in between these harmonics, and they will be at frequencies like 75 or 125 or maybe 325 hertz, something like that. So which means they are not exactly a multiple of the base frequency, so they're not integer multiple. That is why 3 is the correct answer, that interharmonics are frequencies that are not integer multiples of the fundamental frequency. Only harmonics are, not interharmonics. Option 1 is incorrect. Yes, we know that renewable can contribute to harmonics, but they are not the only cause. And option 2, the issue here is lower, because interharmonics, they can basically be higher or lower than the fundamental frequency. And option 4, a special type of third harmonics, no, that is not correct, because interharmonics is not tied to the third harmonics. Great stuff. Now, as we head on to question 3, don't forget to give this presentation a thumbs up and subscribe to CMTEQ channel. That will be highly appreciated. Question 3. This is about receiver circuit design or high Q factor effect. The question is, in which scenario would a receiver with a high Q factor be most beneficial? Option 1, receiving wideband digital signal. 2, isolating narrowband AM radio signals. 3, handling multiple simultaneous signal. 4, general purpose communications applications. Okay, what is the correct answer? Now, before you can reveal your answer to us, let's go ahead and see how the community voted. That will give you some ideas. Great stuff. The majority went for option 2, 61%, which is isolating narrowband AM radio signal, amplitude modulation radio signal. What is the correct answer? Great. Option 2 is indeed the correct answer. But why is this the correct answer? Well, in receiver circuit design, if you've got a high Q factor, as you can see here, that means your system have a narrow bandwidth, which means excellent selectivity. As you can see, a system with a low Q factor, the bandwidth is much wider. And then that will cause you problem with selectivity. And this is obviously ideal for isolating specific frequency that you do not need. A good example will be when you're tuning into an AM amplitude modulation radio stations. At the same time, you are rejecting nearby stations and noises at the same time. So you need to have a high Q factor to effectively achieve that. And option 1 is incorrect, because as per the graph here, you can see receiver with wideband got a low Q factor. And option 3, obviously handling multiple signals require a broader bandwidth or advanced multiplexing system. So this is totally different from simply just having a high Q factor. And it is not option 4, because if you just design a general purpose communications applications, you don't have to have a high Q factor to have better selectivity. All you need for this general purpose communication system is just basically flexibility, the ability to be able to be useful in any type of environment. Great stuff. Now let's move on to question 4, which is also now again related to renewable energy role in environmental sustainability. And the question is, how does electrical energy contribute to environmental sustainability? The options are: 1, it is the only energy source that does not produce emissions. 2, it can be generated from renewable sources like solar and wind. 3, it is the cheapest energy source available. 4, it requires no infrastructure for distribution. Great stuff. Now, what is the correct answer? Let's go ahead and reveal how the community voted. Perfect. 84% went for option 2. It can be generated from renewable sources like solar and wind. This is how electrical energy contribute to environmental sustainability. But is this the correct answer? I'm almost certain this is the correct answer. Let's go ahead and reveal. Indeed, it is the correct answer. Now, let's just add some quick insight on the correctness of this answer. The fact is that electrical energy by itself is not inherently a clean energy, right? Because it depends on how it is being generated. Basically, by using renewable sources like wind here, solars, or maybe hydropower, electricity basically becomes a sustainable option that basically reduce the greenhouse gas emissions and the reliance on fossil fuel. So that's the idea. So now, before we move on to the next question, let's just break down the incorrectness of some of these options. Option 1, it is the only energy source that does not produce emission. Now, this is incorrect because if you generate electricity using coal and gas, you're going to have lots of emissions. And option 3, it is the cheapest energy source available. That is also incorrect because it depends on the region where electricity is being generated. It depends on your power utility. If they decide to increase the unit price, then, well, it's going to cost more. And option 4, it requires no infrastructure for distribution. This is also incorrect because we know that you need a huge distribution network or a transmission network if you want your electricity to reach to your consumers. And again, this is why grid modernizations is so important in the context of environmental sustainability, because it's integrated in its power generation, solar and wind generation. Now let's go ahead and move on to the last question of the day, and this is also related to the electrical grid, specifically the grid tie inverter system. And the question is, in a grid tied solar system, as you can see here, with a hybrid inverter and battery backup, what happens when the grid fails and the inverter is in islanding mode? Okay, this is a very interesting question. Option 1, the inverter shuts down completely. 2, the inverter disconnects from the grid but continues supplying local loads. 3, the inverter continues feeding power into the grid. 4, the inverter switches to MPPT mode only. Okay, what is the correct answer? But before we do that, let's go ahead and reveal how the community voted. Great. The majority, 70%, went for option 2, which is the inverter disconnect from the grid but continues supplying local loads. Is this the correct answer? Let's go ahead and reveal. Yes, indeed, it is the correct answer. But why is this the correct answer? Because in islanding mode, when the grid tie inverter system goes into island mode, it disconnects from the grid because it senses the grid is offline. It disconnects itself, and this is so that in case it enter an export mode where the inverter need to export power back into the grid, it will not do that if the grid is offline. This is because of safety. It does not want to energize the tower here. Maybe utility workers are working on the tower, so it cannot energize that tower again. So it's safety reason. And while it disconnect, it will continue to supply local loads here using solar power or battery backup. Okay, hence maintaining supply continuity even though there is a blackout. So it can actually maintain this for a longer period depending on your system size here, whether you got bigger batteries storage or more solar panels. So this makes option 2 correct. Now let's go ahead and discuss the incorrectness of some of these options. Option 1, no, the inverter will not shut down completely. It will only disconnect from the grid. Option 3, the inverter continue feeding power. No, we discussed that. It will not continue. It will not export power. It will disconnect. Option 4, the inverter switches to MPPT mode only. No, that is not correct. MPPT, which stands for maximum power point tracking, it's how the inverter efficiently pull power from the panel, so it will continue to do that whether it's in islanding mode or in normal operating mode. This is what makes grid tie hybrid inverters so important and valuable, because they basically combine the efficiency of a grid tied systems with the resilience of an off-grid system that can operate without grid. That is it, guys, for this CMTEQ quiz review 4. If you found it useful, interesting, informative, please make sure you give it a thumbs up and subscribe to CMTEQ channel. That will be highly appreciated. Until next time, stay tuned for the next CMTEQ quiz review, and in the meantime, don't forget to visit the CMTEQ community tab for recently uploaded quiz. Until next time, cheers.